Welcome, everybody, to today's episode. Welcome to the podcast. This week, we're doing a People of Science segment. We're going to start that in a second here, and we'll have our talk with Avi Loeb and talk about Oumuamua, this interstellar object that came into our solar system, and all the evidence that we've seen points to us having to come to a conclusion that we may have to change the way we fundamentally think about life in the universe, which then, what kind of effect does it have on us? So, this is a really fun episode. I had a great time. This is the kind of stuff that I started. This is why I got into science. This is the stuff I love. For everyone that's not familiar, my name is Alex Girofanos. I'm an engineer. I podcast on my free time here. We talk about space and science, and I started in R&D, in research and development, doing things in a manufacturing environment for aerospace, and trying to do things that no one else had ever done before. There was a challenge. There was a way to do it, but no one had ever figured out how to do it. So that's where I started. That's where I love being on the bleeding edge, poking something and being like, hey, like, what happens when I do this? What is actually going to happen here? How do I get to my end goal of figuring this thing out? And this whole thing about Oumuamua and this interstellar object that came into our solar system, and we just had a chance to glimpse at it. And like I said, it's amazing. So I hope you really enjoy this. And the phrase I want you to keep in your mind is a quote that you've heard from Sherlock Holmes. It's the same quote you've heard from Spock from Star Trek. And that is, once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. That's what I'll leave you with before we start this podcast. Think about that. Think about how logic will take you places if you actually pay attention to what it's showing you of reality, and how that changes our mind about what's really going on there. So, before we start, again, thank you for being a part of this podcast, joining this podcast, listening. If you want to help support us, obviously share our podcast, whether it's on Apple Podcasts, Spotify, YouTube. Subscribe to the YouTube page. Share with your friends. And also, if you want to help us fund all of our cool projects, all of our science projects, our 3D printing lab, AG3D, is here. We brought some of our stuff into reality. Our newest thing is our Mandalorian helmet magnet for your fridge. Super strong magnet. Really cool, like 3D design for the Mandalorian helmet. You can hold anything, whether it's, even the really thick stuff like holiday cards and things like that. It's great for that, multiples. So it's a fun gift. It's $8, and it makes a great gift for somebody, and it helps support the podcast. So, and we 3D print it for you on demand. You click that button, we run it on our 3D printer, and then we ship it to you. That's how we do it here with AG3D. And with Today in Space, and of course we have our rocket ship phone stand, which we're in the middle of trying out some new materials that have some really cool matte looks. So all of those you can find at ag3dprinting.etsy.com. That's our Etsy store. That's where we're doing most of that there. You can go check that out. There's also a donate button on our homepage at todayinspace.net. We added that. A few people were wondering if there was just a way that people could donate. That is another way you can help fund this podcast, and that helps us fund all the plastic and the basically what it takes to run our 3D printing lab for our projects here, right? This is the Oumuamua model that everyone takes as gospel. This is what it is. This is what it would have been if the reflectivity of Oumuamua was actually taken into account. It actually becomes a pancake, but there's even more, and that's where we really are so happy we had Avi on this, so he could really focus my all over the place brain into really what the mystery is. And the book is amazing. You can check that out. It's in many, pretty much all languages for the most part that would buy books. So it's available. It's out there. The first actual scientific evidence of alien life. I say in the podcast, I want aliens to exist. I want to learn about them. I am pro alien life being out there, but there's really nothing that I, as a scientist, can go like, yeah, that's good evidence. This is actually evidence, and all it does is open our minds, and there's such a restriction to this idea getting out there that we have to do our duty and bring Avi on. He's also an astrophysicist, so it's not like he's just, some random person on the internet talking about it. He's actually talking about the science and the evidence leads us to this conclusion. So, once again, once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. That's our guiding phrase for this episode and for this amazing mystery. So, please enjoy the mystery of Oumuamua, and welcome Avi Loeb to the podcast. Enjoy the episode. Day 2 Today in Space, your space science podcast. I'm your host, Alex Fanos, and today we're doing an episode of People of Science. We get to talk to people who have either worked in the industry or are still working in the industry and figure out where that passion for science came from, and then we dive into where did it take them, what did they take away from it, how are they applying science in their real life, and that mindset of the scientific mindset. How are they using that in everyday life? So this week, I'm very honored to have on Avi Loeb, the author of Extraterrestrial, and it's one of these things, just to go on a quick rant right before I let Avi speak, we talk about a lot the scientific ladder of ideas, and there's hypotheses, which are ideas, we're bringing them into the universe, we're trying to ask the question, and then we're getting data to look back and think, are we right? Are we actually looking at reality correctly? And then there are theories which are actually get tested, they flush out, we're starting to realize what reality is, and then a scientific law, that is when it replicates life as well as we can tell what reality is. And one of the great things that I love are these new hypotheses and new ways of thinking. And Avi is one of the people that has driven one of these amazing hypotheses. I'll let him introduce himself so we can talk about this, about the first interplanetary object, Oumuamua. I hope I pronounced that correct. I've been really trying to make sure I got it right. But Avi, welcome to the podcast.
Thanks for having me.
Of course. So what I want to do is, can you give folks a quick background of who you are and what you do on a daily basis? Because you are, to say that you're involved in science, I was going to go through the list. I'd rather you just explain it. There's so many things that you're doing.
Well, fortunately, it's relatively straightforward because my childhood pretty much shaped the way I am today. So in describing where I came from, you can pretty much understand where I am. I was born on a farm and used to collect eggs every afternoon and go to the hills of the village to read the philosophy books. I was mostly interested in the fundamental questions about our existence. And at the same time, I was connected to nature, less so to people. I was not a social animal, so to speak. And for that, I married my wife, who connects me to people better. But as a young kid, I really admired the philosophy and the humanities more broadly because they address some of the most fundamental questions. But then at age 18, I had to serve in the military in Israel. It's obligatory. And I chose to continue intellectual work rather than run in the fields with a gun. And so I pursued the physics, which I was good at. And I was recruited to an elite program where I could finish my PhD in physics at age 24. And I proposed the project to the Strategic Defense Initiative, Star Wars, back in the mid-1980s, that President Ronald Reagan initiated, and it was the first funded international project, and that brought me to the US, to Washington, D.C. In one of the visits, I visited Princeton, New Jersey, and I was offered a 5-year fellowship under the condition that I'll switch to astrophysics. So I had to learn the vocabulary. I didn't know how the sun shines, and it took me several years. And it was a very competitive environment, so it made me feel quite bad about myself. But then there was a position advertised at Harvard University, a junior faculty position, and the first person that was offered that job declined it because the prospects for getting tenure at Harvard were extremely small. The previous person who got it was decades earlier. And so they offered it to me as the second choice, and I wasn't worried about tenure because I could always go back to the farm. I had plan B. But by the way, I still contemplate that because very often I think that work in the farm might be more relaxing and fulfilling than work in academia. But at any event, I was tenured 3 years later, and then about 14 years after that, I became the chair of the astronomy department for 9 years at Harvard. And when I was tenured, I realized that even though I was, my marriage was arranged by circumstances, that in fact I'm married to my true love. Because in astrophysics, we address fundamental questions that used to belong to the realm of philosophy or religion, such as how did the universe start, or when did life form, and is there life elsewhere? Are we the smartest kid on the block? That's the question I have in my
Yeah.
book. And it's quite rewarding to be able to address these questions with scientific tools. But what makes me different from my colleagues is the fact that I don't care how many likes I have on Twitter. I grew up on a farm. I'm connected to nature. I pay respect to evidence, not to what people say. And
Mm.
just to give you an anecdote, a few weeks ago, my publicist told me, great job, Avi, because I had by now 300 interviews over the past 8 weeks. But just a few weeks ago, he was saying, good job, you are marketing the book very well. It's doing, it's bestseller in many countries. And I said to him, I'm not marketing the book. I'm just, explaining my message to the public. And
Yeah.
if the public wouldn't like my message, I wouldn't care less. I'm just expressing what I think is right. And so fortunately, the public likes it and the book sells, but that's a
Hmm.
byproduct.
Right.
So that's the way I operate. I basically try, just like basketball players, I keep my eyes on the ball, not on the
Mm.
audience.
Mm. I can't tell you how refreshing it is, especially having someone from within academia who's speaking just so truthfully. And I love your honesty about where this all stems from, and I think it really comes down to your mindset just in general. And I think why science suits you so well is you really look for that basic. What is the rude down version? What is the simplest explanation for this? And especially after reading your book and hearing you speak on Joe Rogan and other podcasts, your openness to changing your mind if things come up. Um, Being someone that was in academia with a STEM degree, why is it so difficult for new ideas to happen inside of an industry like academia?
Well, you would think that academia was constructed to allow innovation, to encourage
Mm,
innovation, because there is this concept of tenure where people, after they get it, they don't have to worry about their job security, and they can, take risks and put some skin in the game. But
mm-hmm,
it goes exactly the opposite way, unfortunately, where people, once they get tenure, they start to worry about their image, and
mm,
do not want to take risks and not put skin in the game, because then their chances of getting honors, awards, belonging to honor societies could get damaged. And that's very unfortunate, because the scientific process is all about learning. We are learning
right.
about nature by paying attention to the experiments, and we need to make predictions in order to motivate new experiments and new collection of new clues about what we're dealing with. And Albert Einstein was wrong 3 times in the last decade of his career. He argued that black holes don't exist, gravitational waves do not exist, and
Mm,
quantum mechanics doesn't have spooky action at a distance. And all 3 were proven wrong by experiments. And by the way, quantum mechanics, which was found a century ago, took people out of their comfort zone.
yeah.
And so, you know, that's actually a positive thing, because it tells you that nature is giving you a gift, that's something new that you can learn about the
Mm-hmm.
reality. And if everything was to agree to line up with what we already expected, science would be
Mm-hmm.
extremely boring.
Yeah.
So my point is, for example, this object that we will discuss in a few
Mm,
minutes, I remember leaving a seminar about it, and together with a person that worked on similar on rocks,
mm.
for decades, and he said, this object is so weird, I wish it never existed, which to me was appalling, because it's exactly the opposite approach. And
Right.
I think that many of my colleagues are resisting the kind of interpretation that I put forward, and I go through a lot of ridicule and scrutiny, and I find it to be completely inappropriate. And surprisingly, in the commercial sector, you find the willingness to innovate, to take risks, whereas the commercial sector is all about profit, making a profit, and it's
Mm,
clear that in order to make a profit, sometimes you have to take risks and go in
right.
directions that do not prove successful, because uh, one of these directions might prove successful and end up compensating for all the failures. And That is
Right.
recognized in the commercial sector, less so in academia. And you know, so people ask me, how do you want to correct this culture, which apparently is
Mm.
not doing what it's supposed to do? And I think there should be more rewarding given to people that take risks, that people that
Mm.
innovate. Right now, the system, is composed of selection committee that allocate funds to relatively low risk endeavors most of the time, and it's all about respecting results of the past rather than encouraging discoveries of the future. And
Right.
I think that is one way to change it. Another one is, you wouldn't expect Marie Antoinette to embrace the principles of the French Revolution because she benefited from the system that the French Revolution wanted to change.
Mm.
And so, if the current culture is being is benefiting the group of people that are supporting it, the only way to change it would be to bring young people without prejudice and with a fresh perspective into the system. And so my
Mm.
hope is that my book will encourage young people to change the current scientific culture.
I am so happy that you're on this mission because there's a real need for it, especially I mean we all know what the world is like right now. If you're in the future listening to this, we're in the middle of a pandemic and the world was already getting fuzzy before that. So I've seen so much, especially in this last year, on aliens and predictions and all this, and like I want to believe. I like sci-fi. I like dreaming about new things and possibilities. But there's nothing I could like put my hat on other than like a few interviews where I was like, okay, that guy knows his science. He's probably telling the truth. But other than that, there's nothing to do that. And the Sherlock Holmes mystery of Oumuamua is fascinating to me, and I love it's like you said, your colleague saying that he wished didn't exist. Like those discoveries, those aha moments, like those moments where you have to think. I mean, I worked as an R&D engineer when I first started in the commercial sector, my first job, and that was the bleeding edge. That was no one else had done this before. So you just have to poke it and see what it does. And that's what you were doing with this mystery, and everyone kept saying, "Stop looking at it," instead
Uh,
of, "Wow, we
yeah.
should look at this."
Well, I respect those scientists that looked at the anomalies of Oumuamua. It showed some phenomena that we haven't seen before, and they try to explain it in terms of a natural origin. And I respect that because that's the scientific process. You put
Mm,
explanations on the table for the anomalies. The majority of scientists just make the point that they don't want to discuss it. Business as usual. It's probably natural, and that's it. Well, that's not the way science is done. It's not based on prejudice, it's based on evidence and trying to contemplate what can explain the evidence and then ask, what new clues can we bring to the table that will distinguish between, in this case, an artificial object and a natural object.
mm,
And in my mind, there is a simple way to distinguish. We saw this object, Oumuamua, come from outside the solar system, and
mhm.
there will be more of the same. When I go to the kitchen and I see an ant, I get alarmed because there must be many more ants out there. And so
Right,
there
right.
should be many more Oumuamua-like objects, and we will see another one within a few years, just like we
Mhm.
found this one within a few years. And so the point is, the next weird object that comes along, we can send a camera
Right.
that will intercept its orbit and come sufficiently close to it within the diameter of the Earth, let's say,
Mhm.
a 4-inch camera that will take a photograph of it. And
Right.
a picture is worth 1,000 words. In my
Sure.
case, a picture is worth 66,000 words, the number of words in my book.
That's amazing. Well, and we see evidence of that today, right? The Perseverance rover that just landed recently. Those images being there are such a huge addition, and it's got that new addition of the microphone, so we're adding senses to us
Right.
looking out there.
Now, the
Um,
only reason we might not get evidence is if we assume that we know the answer in advance. And that was
Great
the
point.
mistake made by the philosophers in the days of Galileo. They said,
Mm,
we don't want to look through a telescope because we know that the sun moves around the earth.
right.
And that only, allowed them to remain ignorant. And reality really doesn't care whether we ignore it or not. The Earth continues to move around the sun. And my point is, science really gives us an opportunity to get information about our environment. In the case that I'm discussing, it allows us to ask, is there a smarter kid on the block? We live in a certain neighborhood. It would be worthwhile finding out, right? And obviously, I mean, if you don't put funds in this direction, if you don't fund it at a level, for example, of LIGO, where $1.1 billion were invested in trying to detect gravitational waves, or if you don't fund it at a level of the search for dark matter, which is comparable to this, then how do you expect to find anything? It's sort of like stepping on the grass and saying, look, it doesn't grow. If you don't fund it, you won't find it. People often say extraordinary claims require extraordinary evidence. My point is, first of all, it's not an extraordinary claim that we could find technological relics of other civilizations, because we know that half of the sun-like stars have a planet like the Earth, roughly at the same separation. So there are billions of Earth-Sun systems in the Milky Way galaxy alone. And if you arrange for similar circumstances, you might get similar outcomes. Why should we be special? So I would actually say that it's a conservative, assumption to make that is common sense, that we are not special. But okay, well, even if you accept the idea that it's extraordinary, my point is extraordinary conservatism leads to extraordinary ignorance.
Yeah, I like that. And I grew up in a Greek Orthodox culture. I love my culture. It's one of those things where the religion is tied in with the culture. And growing up, I had a lot of questions with the faith, and I find myself still questioning today. But it was not a popular thing to ask questions, and it's it really is an orthodoxy of thought, and so really what you're pointing at here is that science or academic science as an industry is like a battleship that is a huge ship. It's a huge organization, and to get that organization to turn in very quickly on a new idea that challenges everything that we've thought before that is the cultural,
Right.
like human. That is the human effect of people doing science. That's just because we're
Right.
humans. If we were
Right.
robots, we
Well,
wouldn't have
so
that, right?
that's one complaint that I have, but I have actually a more serious concern, and that is, you might say, okay, people are conservative, they are slow to move, like you're saying, it's a giant ship, slow to move. But there is another issue, which is that a substantial fraction of the mainstream right now in theoretical physics is working on ideas that were never tested against experiments in the past several decades and will not be in the next several decades, like string theory, extra dimensions, the multiverse.
Well, and they're called theories, which is the most from me as I've talked about this in the podcast before. They're not actual scientific theories. They're like theories of like just a general word. It's actually a hypothesis, right?
Yeah, but there is no problem with hypothesis as long as you can put skin in the game, that you make
Right.
predictions based on
Right.
that theory
Hmm.
and test them against experimental data. Now,
Right.
in the context of these theories, there are hundreds of people working on them, but there is no prediction that can be tested. They don't put skin in the game, and you ask yourself,
Right.
how can that be mainstream? Well, there is a very simple reason for that, because if you have this sandbox where you can demonstrate intellectual virtuosity, intellectual mathematical gymnastics, where you show that you are smart, and you don't make predictions so that you cannot be proven wrong. It's all mathematics. That's the ideal setup for not putting skin in the game and getting high reputation, because you claim that you're doing physics, but you can never be proven wrong. And
Right.
great, so then you maintain your high reputation. You cannot ever make a mistake that will be shown by an experiment to be you're going in the wrong direction. Now, I find that unfortunate, because we are supposed to describe nature, and it's just like a shoemaker that decides to bake cakes at some point. So physicists that decide to be mathematicians, it's legitimate, but don't call yourself a physicist, because a physicist is about trying to describe reality and putting skin in the game, just like kids. They get bruised, literally speaking, they put skin in the game.
Hmm.
And in the context of astrophysics, we do that because there is a lot of experimental data and we test theories, and it's all about, if you propose an idea, it's all about the idea standing up to the scrutiny of evidence. And
Right.
so what I find disturbing is that when I am guided by evidence that looks anomalous, I could be ridiculed,
Mm.
whereas at the same time, people that talk about extra dimensions that we've never had any clue for
Right.
are regarded safe, and they can talk about it in the
In career
mainstream, give each
paths.
other awards, and
Right.
everything is fine. So I think
Mm.
something is unhealthy in the current culture. I think people have ideas that can be tested should be
Mm.
the ones that are rewarded, and people that talk about things that will not be tested in the next millennium, should be at the fringes of physics, because
Right.
if we cannot test those ideas, we can never make progress. In fact,
Mm.
there is a whole culture right now that says experimental testing is not even needed, and moreover, you will never be able, even in principle, to prove my theory wrong because it's so flexible. So any experimental result that you will get, I can accommodate by adjusting the parameters of the theory. So I say, what kind of a science is that, where
Yeah.
any experimental evidence can be? I mean, a theory of everything is a theory of nothing.
Yeah. Yeah, no, no. This is that's very concerning. I mean, I left the academia in 2015, and that was not there at that time, at least where I was. I mean, that is so much more of an ego-driven career move than it is a pure science. I want to see what reality is when I poke it.
Right. Right.
Man,
But
that's not
moreover,
great.
this culture, some people in this culture believe that they are carrying the torch of physics forward, and that's the way it's advertised to the public. And I find it really surprising because
Mm,
what kind of a torch is that if it's not tested experimentally?
right.
And at the same time, talking about anomalous evidence as if, it takes some people out of their comfort zone, that is ridiculed. Like we are in a reverse situation with respect to where physics should be.
Right, and holding up physics as a way to look at reality. Like
Mhm.
I know I've talked to a bunch of friends about this, and I know you're of the same opinion, but we have to challenge this back. If the worst thing that can happen to science is for it to become magic, because truth is already a weird subject to even breach on what is real, and if we
Right.
can't have a tool, a device to analyze what's really there, then we're not going to do this. I mean, having a scientific mindset is what got me through uh, getting through my cigarette addiction. I smoked cigarettes for 7 years, and I had to use a scientific mindset to cut through what delusions, whatever the addiction was doing to my brain and my chemistry.
Right.
I mean, that's the same thing we're putting ourselves into here, right?
Yeah, so science is a way of life, as you say. I mean,
Mm,
you can think about any issue in life scientifically.
mm,
When a pipe is getting clogged at my home, then, together with a plumber, we're trying to find evidence for what the origin of the problem is and then solve
mm,
it just the way I try to solve a problem with the dark matter in the universe. To me, there is no distinction between, the scientific method that we apply in academia to what I do in my daily life. I think about every phenomena that I see. I try to figure out what is behind it, and in much the same way, I don't see a difference between the work I do and my life, and I
mm.
don't see academia as being on a pedestal relative to the public. I think the public should be able to understand whatever people are doing in academia, and therefore, this idea that we should tell the public the results only when they are final, I think is misguided because you give the public the illusion that the scientists always know what they're talking about. I sometimes feel like I'm the kid that says that, look, the emperor has no clothes, because most of the time in science, we don't know. There are multiple possibilities, and we need more evidence to be sure. And then, if the public sees the process and realizes by how many steps we have to go before the evidence is conclusive and gives us the definite answer, you know, the, only then the public would appreciate the validity of the conclusion, because otherwise it looks as if we are coming, like lecturers in a class and telling the public what the
Right.
answer is, and that is completely unnatural.
Hmm.
And moreover, when there are press conferences that announce the results, sometimes afterwards, the people that announce the results have to retract it. So it looks completely artificial,
Right.
declaring it as if we know it and then coming back and saying, oh, actually, we didn't really know it.
Yeah, if we don't make it clear that it's also scientific to say I don't know.
Right.
Like how many of those people who are in that theoretical new culture would actually say that they don't know? Probably not a lot, right?
Not many, no?
Yeah, yeah. And that's such a I mean, and look, the scientific mindset has made me more humble and has made me like look at data and be like, I guess I'm wrong. Like
Right. No,
that's
one should be
okay.
willing to be wrong, because that's part of the learning experience. Very
Mm,
often you don't know which path to take. And, when we complain about politicians not paying attention to evidence and believing in fantasies, uh, we should at least make sure that the academic house that we come from is like that. And
mm,
I'm not sure we can justify what's going on right now. The scientific culture should be based on evidence and not on prejudice. It should be open-minded to innovation, to ideas that may take you out of your comfort zone, because that's the way you make discoveries. And
mhm.
that is why I'm doing all these interviews. That's why I wrote my book, because I'm trying to bring the scientific culture back to where it's supposed to be. And
Mm.
we should see if I'm successful. Probably, it will not be easy, but at least I express my concerns.
Yeah, and I've been seeing you out there. I think you're on the bleeding edge of trying to bring a new hypothesis that could change the way that we think about things. I mean, I really do see such a large comparison to the days of Einstein and introducing that idea to now. And I think you're using a very similar approach of going out to the people, not don't stick with the people that think you're and it's dicey because part of you doesn't want to just find a group that tells you you're right, and at the same time you still want those people to be critical if you are wrong. So it's this balance that you're playing
Right.
when you're on the
But
front line of the scientific process here.
yeah, so the way I approach it is basically to describe the evidence. And,
Mm.
maybe I should mention a few details about that.
Yeah,
So
let's break it down.
Oumuamua was the first object that came from outside the solar system that we discovered close to Earth. And we knew that it's interstellar, that it came from outside the solar system, because it moved too fast to be bound to the sun. When we
Mm.
launch a rocket with a high enough speed, it escapes the pull of the Earth.
Hmm.
And the same is true about the sun. So this object was moving too fast to be bound to the sun like the planets are.
Mm.
And it was discovered on October 19th, 2017, by a telescope called Pan-STARRS in Hawaii, and was given the name Oumuamua, which means a scout in the Hawaiian language. And at first, astronomers thought it must be a comet,
Mm.
but it didn't show any cometary tail. There was no gas or dust around it, and moreover, as it was tumbling over 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. So that
Mm.
meant that as it was, its area on the sky was at least 10 times longer than it was wide. But
And just to cut in because I do have some fun stuff here. I 3D printed some models
oh,
of this is the I think what everyone is familiar with, and this is the model you're saying is not correct.
it's
And
not correct.
yeah, but
So
this is the thing that I am here to point out online is it's very important when you see this image online. Even the place I downloaded this model, it's not stating at all that it's showing an artist rendering. It's not saying it's an artist rendering. It makes
right,
it look like we pointed a telescope at this, and this is what it looks
right.
like.
No, so the object was the size of a football field, a few hundred
Wow.
feet, and at the distance of a fraction of our separation from the sun, the telescopes on Earth could not resolve it. We could not get
Mm,
an image. But from the reflection of sunlight as it was tumbling, and here is another
mm,
illustration, from the reflection of sunlight, we could infer at the 90% confidence that intrinsically it's a flat object,
Mm.
pancake
So
shaped.
more like this.
Exactly.
Yeah.
Exactly. But of course, this object, in some phase of its tumbling, it would look as if it's elongated like a cigar when you look at it from a
Right. Like
distance.
if we were
Yeah,
looking at it like that.
exactly.
Yeah. Yeah.
So that's where the notion came from.
Ah.
Anyway, so that's already unusual about this object, and then it also exhibited an extra push away from the sun as a result, and that push was declining as inversely with distance squared, and it couldn't be the result of evaporating gases because we didn't see anything, so there wasn't
Right.
any rocket effect acting on it. And the only way I could explain it was the reflection of sunlight from the object is giving it a push. And
Mm.
for that to be the case, the object had to be very thin, sort of like a sail.
Sort of
And
like a light
yes,
sail here.
exactly.
So this is the with 3D printed. This is the light sail model here.
Nice.
But yeah, so basically, what you saw by the evidence was that it was this extremely thin. What was it? A millimeter thick?
Yeah, less than a millimeter. And of course, it doesn't need to be designed to be a sail. It could be just a surface layer of something else that was
Oh,
ripped apart.
okay.
Or just to give you an example, in September 2020, the Pan-STARRS telescope, the same one that discovered the Oumuamua, discovered another object that was, this time it was bound to the sun, roughly at the orbit of the Earth, and it was given the name 2020 SO. And the astronomers that discovered it realized that it actually came from the Earth, that in 1966, this
Oh, this is
object
right.
uh, is a rocket booster that was launched into space and had very thin walls. And they also recognized that it showed an excess push as a result of reflection of sunlight because it had very thin walls
Mm.
and it didn't have a cometary tail. These facts were known before it was realized that it's a rocket booster. So my
Right.
point is, in this case, we know of an object that was artificially made by us, not designed to be a light sail, but
Mhm.
shared the qualities of Oumuamua. And so the question is, who produced Oumuamua?
Right. Right. Where did this come from? I think you called it interstellar trash, and I think like if I think about as a scientist, if I think about life in the universe, to me the most likely thing that I like to sit with is yes, there's probably other life out there, but are they alive now, like when we
Right,
are? Like our solar system
exactly.
is just one that happens to be in this habitable formation that we're lucky to be in, but when and where and it's
Yeah, so actually for 70 years we've been searching for radio signals. That was the traditional method for finding alien civilizations. And it's just like trying to speak on the phone with someone and you need the counterpart to be alive in order to have a conversation.
right.
We can't have a conversation with the Mayan culture because the Mayans are not alive anymore. And
Right.
so um, uh, we can still find evidence that they existed from relics they left behind, and we can find them in archaeological digs. And
Mm,
um, and so my suggestion is actually doing space archaeology and searching for relics of civilizations. The sun is a relative latecomer. Most of the stars formed billions of years before the sun, and if
mm,
they had a technological civilization like us that sent out equipment similar to Voyager 1, Voyager 2, New
mm,
Horizons, and others, we that equipment will not be functional after billions of years and will be just space trash, as you say. But
right.
it could imply the existence of a civilization out there. And it's sort of like finding a plastic bottle on the beach among all the rocks that are naturally produced.
Right.
And a simple way to tell whether it's a plastic bottle or a rock is to take an image. And
Mm,
that's, I think, the way to proceed in terms of how to identify relics in the future. And it's much better than looking for radio signals because you can collect, you can look at all the relics that were accumulating over time from
mm,
civilizations that are dead by now.
right. Yeah, this is and this is just the breakdown that you had in the book about just how rare this object was, and the actual odds once everything stacked up, how large the odds were of this being a rare object. Um, and the reality is that you really just only have the research you had in that glimpse of a moment, because this thing came in extremely fast. Was it 200,000 miles per hour? Was that the number I got?
Well, yeah, I mean the speed changed along its orbit, but that's another peculiar thing about this object, that it came from a special frame, and that frame is called the local standard of rest. It's the frame that you get to when you average the motions of all the stars in the vicinity of the sun. And
Mm,
so it's sort of like the local parking lot. And this object was at rest in the local standard of rest. Only 1 in 500 stars is so much at rest.
mm,
And the relative motion of the sun and this object was just the motion of the sun relative to the local standard of rest. So it's sort of, this object was like a buoy on the surface of the ocean, and the solar
mm,
system was like a giant ship that bumped into it. And that leads to the question, why was it in that special frame? Clearly
mm.
that is a frame, if you find an object there, it cannot be associated with any star because the stars are moving relative to that frame. But it could, for example, be a member of a grid of objects that are used for as coordinates when you navigate through interstellar space. You want to know where you are, and you do it relative to this object. Another possibility is that it's a member of an array of objects used as relay stations for communication through space.
Mm.
We don't know what it is, but it's definitely peculiar that it didn't move like stars do relative to the local standard of rest.
Yeah, and it makes me think of just how massive the scale is of the universe when we really start talking about how big everything is and how spread out and wild the universe is for us to look at. It
Yeah,
also
it's
makes me think that we have so many limited resources to actually dedicate towards looking at everything. I mean, you discuss it in the book, and it's just a reality of astronomy that there's not enough telescopes for the amount of people that want to look, and never mind to have a full view on the entire sky all the time.
right.
Um,
Well,
and
so
that's kind of. Oh, please go ahead.
that's that was the Pan-STARRS telescope was the first one that had the capability of monitoring the sky to the sensitivity that allowed us to detect an interstellar object like Oumuamua that is a
Mm,
few hundred feet in size, and that dictates how much sunlight it reflects, and you don't
right.
know where it's coming from, so you need to monitor the entire sky. Now, Pan-STARRS was constructed because of a task that the US Congress gave to NASA to find all objects, or not all, but 90% of the objects above a size of 140 meters
Mm,
um, that come close to Earth.
right.
Because we know that the dinosaurs were killed by a giant rock, roughly the size of the island of Manhattan, that approached them. And once it hit the ground, the fun stopped, and three-quarters of all life forms died. And so, the dinosaurs had huge bodies, so you might think that's very useful for survival, but it wasn't really when a rock came from the sky. And we have the human brain, which is much smaller than the body of a dinosaur, but nevertheless, it's much more helpful for survival because we can design telescopes that would identify big rocks when they're heading our way, and then we can decide to deflect them, to nudge them away from Earth. And so that, identifying such objects was the purpose of Pan-STARRS. And in the process of monitoring the sky, it found Oumuamua. And
Mm,
actually, in less than 3 years, there would be a better, much more sensitive observatory called the Vera Rubin
mm,
observatory that would be able to detect Oumuamua-like objects once a month or so.
wow.
And it could identify two-thirds or 60% of all the objects that are bigger than 140 meters, roughly the size of Oumuamua. And about 1% of the size of the rock that killed the dinosaurs. So we are really
Wow.
getting to very small scales now. And altogether, this Vera Rubin Observatory will be a very good alert system for interstellar objects that we can then observe and check, which one looks more like an artificial object than a
Mm,
rock. And of course, if we find one, we might land on it and
right.
import that, try to understand the technology, and perhaps, that will give us a leap
That
in
would be
our
crazy.
technological advance.
Yeah, no, that would be wild. It just makes me like we could have missed so many interstellar objects already because we
Right.
just don't have the capability to see it.
Yeah, so the small ones, smaller than the size of a football field, we can't really see within the orbit of the Earth around the sun unless they come very close to Earth,
Mm,
or they appear as meteors,
right.
But
And it's too late at that point.
and also very fast ones, there could be objects flying at a fraction of the speed of light, and we
Mm,
just don't notice them because astronomers dismiss these things. When something flies so fast across the sky, nobody pays attention.
right. No, this is this is really exciting stuff. And I guess what is the next step? What do we need to do? I think you're regardless of how far you push this ball, I think what you are doing with this book and pushing this hypothesis is getting more of us to start thinking about the idea that's out there and potentially can get a movement to get more eyes in the sky, right? So we actually have a chance to catch the next one.
Yeah,
Um,
no, so we will definitely catch more because the
mm,
Vera Rubin Observatory will identify many more, and also pan-stars, every few
right.
years we'll find one. But my point is not so much about finding more as it is about what to do. And
Mm,
so my strong recommendation is to design a mission that will bring a camera very close to such an object that looks as weird as Oumuamua, and the Vera Rubin Observatory might find such an object a year in advance of it passing close to us. So we have a year to launch a spacecraft to come close to it if we know its orbit.
right.
And
So we're looking to launch a spacecraft
well,
as soon as we notice it.
that's my recommendation with a
Okay,
camera that will take a close-up photo because I think that's the way for us to conclusively learn about
I
the
love it.
nature of such an object. And of course, there is no reason to obsess with Oumuamua because by now
Mm,
it's a million
it's gone.
times fainter than it
Yeah.
was close to the sun, and it's too far away. We can't chase it.
Hmm.
But as I said, there is no reason to expect us to have had some privileged time in 2017. I mean, these things happen all the time, and we happen to
Mm,
look at one, and so there will be more. And we should just keep our eyes open and not assume that it's always rocks. It's
right.
never aliens, like some of my colleagues say.
And it's weird to think that it's that difficult of an explanation. I'm already okay with the idea, so for me, I just wanted to jump on and learn more. Um, is it because it's mixed in with sci-fi? Is it like what do you think? Where at this point with you've just done 300 recently, and you've done so many more over all this time. Where do you think this is stemming from?
Well, I would have expected some of my colleagues to hug me and say, "Great point, Avi. Let's, put some more telescope time, search for more objects of this type, and the next weird one, we'll try to collect as much data as possible, and perhaps even launch a camera that will take a photograph." I would expect that to be sort of embraced. Why not? Science is supposed to
Right.
be exciting, but instead they say, "Oh, this is bad for. Let's not even talk about it. It's just a rock. Stop speaking about it. It's an embarrassment to discuss it." It's really, so I find that disturbing because, there is nothing that appears to be more compelling. I mean, people have tried to explain the anomalies of Oumuamua and the scenarios that people came up with as natural
Mm,
origin. Let me give you the examples. One is a hydrogen iceberg, so that when it evaporates, you don't see the cometary tail because hydrogen is transparent. And the problem with that scenario is that a hydrogen iceberg the size of a football field will get completely evaporated in a relatively short time scale by absorbing starlight, and it would not survive the
mm,
journey. Not to speak about the fact that we've never seen such a thing.
right.
Then there was this suggestion maybe it's a cloud of dust particles that are loosely bound, like a dust
Mm,
bunny, 100 times less dense than air. And the problem with
mm,
that suggestion is, it doesn't have the material strength to withstand the heating to hundreds of degrees when it comes close to the
right.
sun.
Right.
And then there was a suggestion maybe it's a fragment, a shrapnel from the disruption of a bigger object that passed close to a star. And here again, you would end up with an elongated cigar-shaped object rather than pancake-shaped object. So these are the possibilities put on the table, and I say they don't look very compelling because each of them has a flaw. And until someone brings in something that explains all the anomalies, um, we should at least allow for the possibility that it's artificial to stay on the table, right?
Right.
And to me, it's common sense. And why should we have prejudice? Why should we always, the point is that this hypothesis motivates collecting more evidence, more data.
Right.
Saying that it's never aliens would argue that, we should just stay in our comfort zone and never check. And
Right.
that to me is disturbing because obviously, if you're not willing to discover wonderful things, you will never find them.
Mm. Well, and what do you think about this scenario? Let's say a few years go by and there is more of this evidence, and the scientific community isn't there to, and I know you'll be there, and I know I'll be there, but if they're not there to talk about it, what does that do to, from a philosophical sense, what does that do to science? What does that do to just everything that we know of today?
Well, I think it will be a problem for science because this kind of objects will come back again. And, if we have the Vera Rubin Observatory, then there will be many of them discovered. And, you can ignore one, you can ignore two, you can ignore three, but once you have a dozen and they all look peculiar, someone will, there would be someone somewhere that will not be silenced. Okay, and
Mm,
that someone somewhere might get more data and it would look as if indeed it's weird. And at some
mm,
point, so if we talk about decades from now, centuries from now, at some point it will become clear, and even if it's of natural origin, it must be something that we've never seen before because these were the suggestions brought to
right,
the table. And so
right,
my point is we will learn something new because there need to be factories of these unusual objects. And
right,
given that we will learn something new no matter what, why not just collect more evidence? And I think it
right,
will be so compelling that people, we are not in the dark ages in the sense that telescopes will continue to collect information about the sky because they are motivated by something else to find those asteroids that endanger the Earth, the near Earth objects. And so they
mm,
will monitor the sky and not necessarily discriminate against objects of this type. And therefore, these would be found. And then at some point, it will be an embarrassment if the scientific community just shies away from each and every one of them. And
mm,
I cannot imagine a situation where there would be a global conspiracy to just ignore these things and say they are rocks, because that would resemble a caveman seeing a cell phone and saying that it's a shiny rock again and again and again, and at some point,
mm,
it would not make much sense. So even if the philosophers put Galileo in house arrest, even though they did that,
mm.
eventually the truth came out, and that's I just hope that it will come out when I'm still alive. That's all.
Yeah. Yeah, no, and it I think it's a great plan. I mean, at this point, we've seen this play out through history. We talked Galileo, we've talked about Einstein, and all these other. There's plenty of others. Um, it's a game of waiting it out so that the idea just loses steam. Really, that's you're basically like this. There's a really good possibility this is coming. So get ready. And everyone's like, I don't know if I'm ready for this. Basically, is it's what
Right.
they're telling you with their
But it's
responses.
unfortunate. I'll tell you why this is unfortunate. It's not just a hypothesis about something. It's This question is the most fundamental question that will have a huge impact on society.
Mm,
If we find that there are objects of other civilizations out there, it will change the way we think about our place in the universe, about our aspirations to space, exploration of space. It could affect religious and philosophical beliefs that we have,
yeah,
and the way we view humanity. What is our future? And it's just a huge impact. I don't think there is any other scientific question that is more important. And
mm,
so I call it Oumuamua's wager. Given the
mm,
significance of the answer, we just cannot ignore it. It's
right,
just a mistake to ignore it. Now, if it was the nature of dark matter, on which, by the way, we invested 1,000 times more money to search for, so even though we invested 1,000 times more money in search in the dark for the nature of dark matter, we haven't found what it is. But think about it, even if we found what it is, if it's an axion or a weakly interacting massive particle or
mm,
whatever, it would have zero impact on our daily lives,
mm,
right? And we
yeah,
invest those hundreds of millions. We detected gravitational waves. What effect does that have on our daily life?
right,
Practically nothing. and we invested $1 billion in that. So how come we invest hundreds of thousands of dollars of federal funds to search for technological signatures, compared to hundreds of millions or billions in other directions? And that makes no sense to me whatsoever.
Yeah.
And given that the public is so excited about this question, how is it possible that the scientific community will not only shy away from it and ridicule a person like myself, but also ignore altogether the public's interest? I just cannot understand this situation, and that's, I've never seen something like that. Where there is such a fundamental question that the public cares about, and the scientists starve the public, even though they have the instruments to address it. And this starvation is evident from the popularity of my book. The reason that my book gets so much attention is that the public never hears a scientist talk like me.
Right. No, and I mean, if we're all looking, I mean, I don't know about you, but I know I'm looking for something to hook my hat onto for what we're going to do to have a fantastic future. The world has not been that great this last year, and the timing of everything. I mean, even if at the basic, everyone wants to know how we're going to get out of this. Like we have this object come through, and we, like, it's there. It's looking at us, and we have this opportunity just to open our minds for a second. We
Right.
don't want to. It's wild.
Well, but the public does.
The
And,
public
and the
does.
amazing thing is that when my paper came out in 2018, it was just around the time of the State of the Union address of Donald Trump. And my paper got more publicity, more coverage in the media than the State of the Union at the time
Bravo.
on the same day. And I was asked about it by Michael Smerconish from CNN. And I told him, the public is probably looking for uplifting news from the sky, and I wouldn't be surprised if that's why even now people are very excited. And by the way, why should science be boring? Why
Yeah.
why can't science be exciting? Here is a question that we can address with existing instruments and telescopes that will captivate kids all over the world that could become scientists as a result, And by the
Right.
way, when I wrote my book, I said to the publisher that my hope is that there will be one kid somewhere that will decide to become a scientist after reading my book. And then a week ago, I had a woman from Malawi in Africa write an email to me and she said, your book is great. It might inspire me to become an astronomer. And I told her the story about the publisher, and I said, are you the one? Are you that person that I was hoping for? And she said, maybe. So I'm already satisfied.
Then you're winning, my friend. Man, there's so many people. I think the our listeners, we've got a nice community here. It's people that grew up and found STEM as a class a hard thing. Tests gave them anxiety, and anytime they think of going back to school, it gives them stress. And other people who went through the gauntlet of STEM education and now don't work in the field that they went to school for. I think there's so many of us that want to explore different things. A lot of us found ourselves out of it because we just found a place in science that just didn't fit us, the passion that came with why we got into it in the first place, right?
Right.
And I think that's our mission here, is to try and get those people back into where
Exactly.
where the passion connects with the science. And
Well, so you see, a lot of scientists elevate science on a pedestal and make it introduce a disconnect between the public and the scientific endeavor, and that, I think, is a big mistake. They should be on the same level. The public should understand what science is doing, and the public should affect what science is doing. We can't just be in an ivory tower where we research problems that have no connection to the public, because like it may resemble asking how many angels can sit on a pin, and frankly, many of the topics being discussed now are resemble that. And I think it's misleading to tell the public science is carrying society forward when we are dealing with how many angels can sit on the tip of a pin. What is relevant is to say to the public, what do you care about? And if the public says, I care about the question of, are we alone? then try to use your instruments. Put the $1 billion in that direction rather than in detecting gravitational waves or dark matter. I mean, obviously, these are important questions and we should follow them. But and in fact, my point is that there is even a culture that doesn't engage at all in the dialogue with experiments.
Mm.
So we got into a situation that is completely removed from the public, which I
Mm.
find to be disturbing, and I think it should be remedied. And most importantly, I think that innovation should come back to academia in a major way, and so that academia should be significantly more innovative than the commercial sector, rather than being comparable or even lower
Right.
at the level of innovation.
Yeah, and do you see academia being able to adjust to that? Is it going to be something completely different? Is there going to need to be something that comes out? Are the
Well, I
businesses going to
think
need to get involved?
it's the reward system that needs to
Mm.
change, and currently the reward system, like allocation of funds through federal grants or
Mm.
allocation of prizes or honors and so forth, are geared more towards established things that are already known, nuances on known themes,
Mm.
rather than encouraging people to embark on completely new endeavors, and as a result, people don't take risks. If people if scientists were realizing that there is more to gain by going in risky directions, they would do it. But
Mm.
the culture right now cultivates a completely different approach, and that's partly because many of these selection committees are populated by the same people that promote this culture, and it's a lot about building echo chambers of students and
Mm.
postdocs that repeat the same mantras that the advisors said for years, so that it will make the voice louder, and the mentor, the main professor, will get more
Mm.
recognition and appreciation. And
Right.
that's not really the goal of doing science. We want to understand nature, not to improve our self-esteem.
Yeah. No, it's I'll be interested to see how things shape out with that. I think one of the things that I'm looking to try and do is find a way to free up scientists that are stuck in debt, to get them to free up so they can think about the things that they want to do. I mean, I myself, I'm still paying off my student loans, so I know what that does to. I've had to work very hard to do this on a regular basis, to get this show, to do what I want to do, just because the reality of loans, and I think that's this next generation that you're talking about. That's a big problem for all of us, and we are there. That's the problem ahead of us. That's what we've got to solve. So. In my way, that's what I'm hoping to do is enable more of those people. We'll see how that turns out. But
Well, the other issue is, of course, there are more people trained in the sciences than those that can get a job, and
mm,
so there is an imbalance between a number of available jobs and the number of people being trained. And and I do think that science is so important for the future of the nation that it should receive more funding,
yeah,
frankly speaking, than it used to in the distant past. Because by now, of course, the science advisor to the Biden administration is now in a cabinet position, which is a very good development. It should have
mm,
been like that for decades. And
yeah,
but at the same, that's a political arrangement. But at the same time, there should be much more funding allocated for science,
hmm,
not just incrementally increase, but an order of magnitude increase, because
sure,
science is really helping society in many different ways.
yep. And so much. I mean, not to get off on a tangent here, but so much of what has happened with the pandemic and with just the inability to explain the actual sciences ahead of us, like the inability for us to say we don't know yet, we're going to figure it out in the beginning, was such a huge blow to the confidence in anything that would have become a vaccine eventually, or like we as leaders in this country just did not have any kind of scientific way, and it's been very frustrating. I mean, I've talked to plenty of
Yeah,
my friends in the scientific community. I'm sure you've had the frustration too, just to see it
right.
keep rolling down the hill. It's almost like we were better off like the Spanish flu earlier, where we
Yeah.
didn't know any better.
Well, so there are two things. One is that scientists should have been allowed to enter Wuhan early on, so that it would have helped them diagnose the nature of the disease and develop a vaccine even earlier, because
Right.
obviously the vaccine is the key. So sharing of information, which is a fundamental facet of science, argues for international collaboration.
Hmm.
Politics should not block international collaboration on science. And that's an important lesson because right now we share our fate globally. A virus coming from one country affects another.
Right.
And therefore, sharing of information is essential
Hmm.
for all of us to cope with it. And unfortunately, that was not the case initially.
Hmm.
And obviously, honesty and being humble,
Hmm.
not trying to claim that we understand something when we don't. And, you know, uh, evolving our perceptions of what the risk is as more and more data comes along.
Hmm.
And, one of the things I learned from astronomy, from the sky is to stay modest. We realize the universe is so huge and we are so small. Also, we live for such a short time, just 100
Hmm.
years or so out of 10 billion years of the age of the universe. And, we are born into this stage without a script. We are not told what the meaning of life is. And
Hmm.
so we are actors in a play, but without a script. So, science allows us to figure out what is on that stage, how, as big as it is, clearly we're a very small component, and we should be modest. And what we were discussing before about my book is basically trying to figure out if there are other actors on the stage
Hmm.
and what are they doing.
Right.
That's also a very elementary question. And why would my colleagues say, oh, there are no other actors, we're special, unique, or give me extraordinary evidence that there are other actors and only then I'll give you funding or support? That should not be the approach. We
Hmm.
should just try to, invest effort to find evidence for something that we already know exists, which is us, okay?
Yeah.
And look for it elsewhere. And so altogether, this sense of modesty, we know so little. The knowledge that we have is an island in an ocean of ignorance, and it's a learning experience. So we can make mistakes along the way, and not fully understand things. But it's not about us; it's about learning on the world around us. And
Right.
the same applies to the vaccine. Initially, we didn't know enough, and of course, as time went on, there was more and more data.
Hmm.
And then, the political system should have been geared around the knowledge that keeps accumulating. So early on, you have to be very cautious because the uncertainty is huge.
Right.
But as you narrow down the uncertainty, as you know that masks are helpful, then you start making policy based on that. And
Right.
so all I'm saying is that, science encourages international collaboration. That's point
Hmm.
number one. And second, that it's evidence driven. And
Right.
so before you have the evidence, you should be modest and not decide about policy until you know what to do.
Mm. Yeah, no, and one of the things that it just happened before this phone call happened, but SpaceX just landed their Starship SN10 for the first time, 10-kilometer hop. They've tested a new technology that's never been done before on their third try, and they're one of the best. That's why we follow them so closely, is because this they are a pure innovation driven like company. They fail fast, they learn fast, and they get it done. And uh, literally before this phone call, an hour before this phone call, it was still a question on whether or not going to Mars is a question. And now I'm still processing like it's they figured it out. Now they're just going to keep going, and it's having those milestones and being aware of it is so wild.
Yeah, yeah.
What is
And
yeah.
one of the things I should caution about with respect to going to Mars is that, on Mars there is no atmosphere and that there is no strong magnetic field that would protect people from the dangerous cosmic rays. These
Mm,
are energetic particles that do a lot of harm to our bodies if we are exposed to them for a year or so. And
right.
uh, that's a risk that one has to attend to before sending people that way, because otherwise they will find their death within a year
Right.
standing on the surface of Mars. It was not evident from the movie, the film, The Martian,
Mm,
but it is a major issue how to protect people, the human body,
mm.
from cosmic rays.
One of my favorite solutions to that is using the regolith itself. It's already
Right.
doing it and going underground. I think that
Yes.
makes the most sense. I mean,
I
I
agree.
personally, I'm waiting for the combination of 3D printing in space to really happen so that manufacturing can happen anywhere. And that will enable so many different things. That's
Yes.
the near future I'm looking forward
Well,
to.
we started from being in caves, right? And we will
Hmm.
end up in being in caves on
The
Mars.
first Martians came out of caves. Yeah, I like that. I like that. Well, Avi, thank you so much for being on. We're running out of time here, but um, let's close out with a final message here. What obviously people can find your book. It's in physical format. It's an ebook. I've read the audiobook. I'm still going through it right now. The book is great because it's got a lot of the actual data in there, which I loved. What's your message for everybody?
My main message is stay curious and stay young in your attitude. It's not a
Mm,
matter of age, and a
mm,
lot of people lose their curiosity as they grow up. It's sort of like losing your sharp edge
yeah.
as you bump against the walls throughout your life. And I try to maintain my childhood curiosity, and people that know me would tell you that I pretty much am the same as I was as a
Mm,
teenager, and I really advise everyone to maintain that. I was asked by the Harvard Gazette, what is the one thing you would change about the world? And I said, I would like my colleagues in academia to behave more like kids. Because kids are fun to play with. That
mm,
you just explore you try to learn about the world, and sometimes you get bruised, but it's all a fun experience. It's exciting,
yeah.
and science should be just like that.
Mm. Avi, thank you so much. Where can people find is the book pretty much everywhere? Where can people
Yeah,
find it?
it's
Is there a
it's
website they
everywhere.
should go to?
In every store that sells books, you can find it, and it's going out to 26 editions in 23 languages worldwide, and it's already bestseller in many countries. And I really hope the message will come out, and of course you can find more stuff about what I work on and my Scientific American articles that I publish once every week or two on my website at Harvard. If you just Google my name, you will find it.
Fantastic. Avi, you are doing what we are is our mission here, which is spreading love and spreading science. So we appreciate you. Your message is getting around the world. It's exciting. Thank you again for joining us. Everybody, make sure to spread love and spread science. Be well, and we'll see you next time on the next episode of Today in Space.
Thanks for having me.